So good morning to you all. So in this episode, in today's online class, I'll be discussing with you what is polymerization, what are the different types of polymerization, and of course, the mechanism of polymerization. So in my earlier class, we discussed what is a polymer. So just a recap, polymers are macromolecules which are formed by repetition of simple molecules called monomer. And in polymer, these monomers are held together by covalent bond. So ice also is a collection of water molecule, but we could not consider ice as polymer because in ice the water molecule are held together by hydrogen bonding. And in polymer, the monomer are held together by covalent bond. So simple example of polymer is polythene, where large number of ethylene molecule are joined together to each other by simple covalent bond. Then polymers can be classified type of monomer, homopolymer. We have a single type of monomer like in polythene or PVC. And in copolymer, we have two type of monomer. One is your adipic acid and the other one is hexamethylene dianiline. Then dacron, it is a copolymer of ethylene glycol and dimethyl terephthalate HF. Now again, polymers can also be classified based upon the type of polymerization. So as already I discussed with you, what is a polymerization? Polymerization is the entire process by which monomers get converted to polymer. And polymerization, there are two types of polymerization. One is called the addition polymerization, or it is also called the chain growth polymerization. The other one is condensation polymerization, which is also called step growth polymerization. In addition polymerization, what happens? That means all the atoms of the monomer are present in the polymer. That means in addition polymerization, there is no byproduct form. And addition polymerization is generally take place with olefin monomer, where the olefin undergo self-addition to give the polymer. And in case of condensation polymerization, it takes place by bifunctional monomer. And in the process, simple molecule is wasted, like water or alcohol molecule is wasted. So if the polymer is formed through addition polymerization, then we can call it as an addition polymer. And if the polymer is formed by condensation polymerization, then we can call it as condensation polymer. So again, addition polymer and condensation polymer is the basic difference. In addition polymerization takes place without the loss of any simple molecule like water or alcohol. And in condensation polymerization takes place by loss of some simple molecule like water or alcohol. So now we will go to share a PowerPoint with you, and there we will be discussing what is the mechanism of polymerization, what is the mechanism of addition polymerization nowadays, which is called the chain polymerization, and what is the mechanism of condensation polymerization. So here I go. So based upon polymerization, we can distinguish polymers as addition polymer and condensation polymer. So addition polymer formed by repeated addition of monomer molecule possessing double or triple bond. So here there is no byproduct is formed. And in condensation polymerization, what happens? Formed by repeated condensation between two different bifunctional and trifunctional monomer unit, and in this process, simple molecules like water or alcohol is lost. See, the process of converting monomer to polymer is called polymerization, and there are two types of polymerization. Addition polymerization, monomer react to form polymer without net loss of atom. So here you see this is vinyl chloride. What is this? This is vinyl chloride, and vinyl chloride is undergoing polymerization to give polyvinyl chloride. And here you see in polyvinyl chloride, all the atoms present in the monomer are present in the polymer. So here there is no loss of simple molecule. And addition polymerization generally take place with monomer which have double or triple bond. That means they take place through monomers which have olefin unit. So one another example of addition polymerization is polythene. So in also polythene, the ethylene unit get joined together by carbon-carbon sigma bonds, and this carbon-carbon sigma bond is formed through the carbon-carbon pi bond in each monomer. And in this process, no simple molecule is lost. So we call it as addition polymerization, and the polymer is called addition polymer. So these are some examples of addition polymer. So monomer ethene, this is the structure of ethene. You get polythene, monomer vinyl chloride, we get polyvinyl chloride. The monomer is styrene, we get polystyrene. Your monomer is acrylonitrile, this is your acrylonitrile, and a polymer is called Orlon, etc., etc. So here what you can see that addition polymerization takes place through vinyl monomer. That means the monomer which have carbon-carbon double bond. So these are a lot of addition polymer. Now mechanism of polymerization classification. Kr in 1929 he called them as addition polymerization and condensation polymerization. And later on H.F. Marx in 1950 he called addition polymerization as chain polymerization and condensation polymerization as step polymerization. So this is a chain polymerization. The functionality is provided by double bond. So as I already told you, that functionality is the reactive part of the monomer which take part in polymerization. And in case of chain polymerization, that is the addition polymerization, functionality is provided by double bond. And in the step-growth polymerization, like which we call earlier as condensation polymerization, functionality is provided by functional group like carboxylic group or phenolic OH or amine group, etc. Now let us examine the mechanism of chain polymerization. As I already told you that addition polymerization is also called as chain polymerization because polymerization takes place by a chain mechanism. So every chain mechanism can be classified into 3 different steps. It contains 3 steps. One is called the chain initiation, then the other one is called the chain propagation, and the last one as chain termination. Now, all chain mechanism can again be classified as free radical chain mechanism or ionic polymerization, that is anionic and cationic. In free radical polymerization, what happens? The polymerization takes place through free radical intermediate. So when free polymerization takes place through free radical intermediate, then we call it as a free radical polymerization. And when polymerization takes place through ionic mechanism, that ion may be a carbon ion or it may be a carbocation. That means the intermediate may be an anion or it may be a cation. Anionic intermediate involves carbon ion intermediate and cationic intermediate involve carbocation intermediate. So when polymerization takes place through ionic mechanism, then we call it as ionic polymerization. And ionic polymerization can be further classified as what? Anionic polymerization and cationic polymerization. Now we will be discussing one by one. What is a free radical polymerization? What is anionic polymerization? And what is cationic polymerization? First of all, free radical polymerization. So free radical polymerization takes place through a chain mechanism. And the chain mechanism involves free radical intermediate. So as you already know, free radical intermediate are formed through homolysis or homolytic fission, and free radical reaction generally take place in presence of heat and in presence of high pressure. Generally, the free radical intermediates are produced by very high temperature and at very high pressure. So, free radical polymerization, it takes place by a chain mechanism through free radical intermediate, and all chain mechanism take place through three different steps. The first one is called the initiation, second step is called the propagation, and the third step is called termination. So here we go, free radical polymerization. The first step is initiation. Now, initiation is the step where free radical is generated. So as you already know, free radical can be generated at high temperature and high pressure, and they can be assisted by the presence of free radical generators. So free radical generators are unstable compounds which decompose at high temperature and pressure to produce free radical intermediate. Now I will go to the board to discuss this mechanism in the board. Then I will again come back to the PowerPoint. So as I already discussed, that free radical polymerization takes place by a chain mechanism, and it is called free radical polymerization because it takes place through free radical intermediates, and free radical intermediates are formed at high temperature, pressure, and in presence of free radical generators. And these free radical generators are normally unstable compound which decompose at high temperature to give free radical. So the first step in chain polymerization is initiation. Now in this step, free radical is generated, and these free radicals are generated through free radical initiator, and these free radical initiators may be what? It may be benzoyl peroxide, and this is a benzoyl peroxide C6. This is your benzoyl group. Then we have the peroxy linkage. This is the peroxy linkage. Okay, so it is called benzoyl peroxide. Now, when you supply heat, then there will be homolysis here. This peroxy linkage will be broken. One electron will shift to this oxygen, the other one electron will shift to this oxygen, and we will get two C6H5 CO. And here carbon dioxide will get released. You can see CO2 minus CO2, and you will get a phenyl radical. So one way is to generate free radical is using free radical initiator like benzoyl peroxide. Then we can use another free radical generator which is called ABIN. This ABIN, and ABIN stands for, A stands for azo, B for peace, iso butyl nitride. So ABIN stands for azo, bis, isobutyl nitride. Now what is azo, bis, isobutyl nitride? So this is the azo group. You already know. This is the azo group. Azo, bis means there are two units of isobutyl nitride. So isobutyl is group. CH3. So butyl means 4 carbon atom, and there is a nitride group. This is isobutyl nitride. So there will be two similar groups in both sides. Now, when I supply energy, heat, then here nitrogen gas will be released. Can you see? So delta triple bond minus nitrogen, and what we will get? So this is a free radical. This is also a free. So chain polymerization or addition polymerization may take place through free radical intermediate. Then it is called a free radical addition polymerization. And free radical addition polymerization take place in presence of free radical generators. And these are two free radical generators which I am discussing. One is the benzoyl peroxide, and the other one is the ABI. I think it is the BN. ABI BN. ABI BN. That is the SO bis isobutyl nitrate. And under thermal mode, they will undergo homolysis and they will get free. So this is the first step of free radical polymerization, that is generation of free radical intermediate. Then what will happen? So these free radical generators will produce free radical. Now suppose we consider the polymerization of ethylene, polymerization of ethene. Then this is the free radical generated from the free radical generator. Then I take this is one monomer ethene. Then what will happen? The free radical will attack the pi bond. You get a new carbon sigma bond here, CH2. So this pi bond, two electron, one electron is involved in forming this sigma bond. The other electron will jump over to the other. So this is the newly formed free radical. So this is how the free radical generator generates free radical. First of all, the free radical generator will produce a free radical, and that free radical will attack another monomer to give a newly formed free radical another free radical. So the initiation has started. The chain initiation process has started. Then the second step will be chain propagation. And in chain propagation, what happens? This newly formed free radical, this one, it will attack another monomer. You will get another free radical. You get another free radical. And this free radical will again add to another monomer. You will get another free radical. Then that free radical will add to another monomer. You will get another free radical. And this process will continue. So the newly formed free radical will add to another monomer to give another free radical. That free radical will add to another monomer to give another free radical. And in this process, thousands, millions of monomer will be incorporated into the polymer chain to give you a linear polymer. Will give a linear polymer. So this is how the chain propagates. Then the reaction will take place as long as free radicals remain in the reaction medium. And in order to stop polymerization, what will happen? You have to stop the growth of the polymeric chain. And the last step, it is called, what it is called? It is called the chain termination. So let us discuss how chain termination takes place. So chain termination may take place by several. One is by coupling. In coupling, what happens? Two free radicals will join together. So suppose this is one free radical R CH2 N R N. Then when two free radicals combine together, it will result the formation of what? Of a new covalent bond. Here is a new covalent bond. So through coupling, two free radicals will join together and a new covalent bond will be formed, and in the process no free radical is generated. Then free radical termination can take place through disproportionation. And disproportionation, what happens? R CS2, let us say N, then CS2. This is one free radical. So two, in one there will be a removal of hydrogen. So in one case there will be a removal of hydrogen. You will get R CS2 M CH. So one hydrogen is removed. So this molecule is undergoing oxidation. And in the other one there will be a reduction. R CS2 and CS2. So you see, so this proportionation means self-redox. The same species undergoing oxidation and the same species undergoing reduction. So two molecules of this radical, one is undergoing oxidation, hydrogen is removed from here and you get a double bond. And in the other case, the hydrogen is added to this carbon and you get this. And in addition to this, there are free radical terminators. There are certain compounds which we can use in chapter. So here I have discussed how addition polymerization takes place through free radical intermediate, and it involves three steps, that is chain initiation, chain propagation, and chain termination. Now I will go to the PowerPoint to show you the same thing in the PowerPoint. Okay, here this is the PowerPoint. So initiation, it is initiators are thermally unstable compound like benzoyl peroxide or AI, BN, azo, isobutylene nitrile. And these free radical generators, they will undergo homolysis to give free radical, as I have already shown you in my PowerPoint. Then initiation, this free radical from the free radical generator will add to the carbon-carbon double bond, and it will give rise to a free radical. So this is the benzoyl peroxide undergoing it. This one I have already shown you. The radical will add to another. This is a sorry. So radical will add to another ethylene molecule I have shown, and these are the disproportionation. Chain termination. There are two types. Combination I've already shown you. Two free radical units will combine together, and this is the disproportionation. So I hope this presentation is helpful to study free radical polymerization. And in the next class, I'll be discussing how anionic addition polymerization and cationic addition polymerization take place. In anionic addition polymerization, it takes place through anionic intermediates, which are carbon ion. And in cationic addition polymerization, they take place through cationic intermediate, which are carbocation. So I have been able to clear your doubt regarding addition polymerization. So in the next class, we'll be having some more interesting topics of addition polymerization, that is polymerization through ionic mechanism involving anionic intermediate or cationic intermediate. Thank you.